My name is Slaven Damjanovic. I am the CEO of the company named GLAMOS. We are coming from Croatia, beautiful city of the Split. I am electrical engineer. For last 6 years, since 2017, I am involved in LoRaWAN technology. And my first project was the system for monitoring agricultural fields. But in the last 6 years, all projects I was involved included somehow LoRaWAN technology. LoRaWAN is really powerful technology, but it is pretty complicated. A lot of parameters can affect signal quality, a lot of parameters can affect the complete deployment. What really can affect everything? So spreading factor is one of the most parameters. It can affect the battery life, it can affect that whole system can work good or whole system can fail. Also, antenna you used on your devices or transmit power can affect also the signal quality and the range you can get with LoRaWAN technology. There are some other things that can also affect the complete system. Why is this important? Because one change of parameter can affect your whole system. And today we will talk about how to handle some of these things to get the best results. So 6 years ago, there was no LoRaWAN network anywhere in Croatia, also in Europe, a small number of networks. So we needed to deploy our own gateways for our own use cases, and it was really hard because we could not find the good location. When you deploy your gateway, you don't know will that work, how good signal is. Then you go in the field, you install your sensor, and when you plug it on, it is not working. What is happening? Why it's not working? Then you need to reinstall everything, move it further away, and a lot of problems. Then only one field tester was available on the market. That was Adeonis field tester, pretty familiar to everyone. But Adeonis is pretty limited device because it did not allow us to change spreading factor to understand where is the signal better with parameters we wanted to have, we wanted to set up. For that purpose and for that reason, I decided to develop my own tool that will help me to set up my devices to understand where is the best signal quality, where can I get the best setup to increase battery life. Currently, this is a device. It allows you to set up any possible LoRaWAN parameter through the screen. You don't need to reprogram anything. You just go on the field. With few clicks, you can set up anything you want. But okay, you want to deploy your network. You have a good location for your gateway. It is high above the buildings, but is that good enough to have the good setup? Well, it can be or it cannot be. This is one example. What can you do? You can find some of the available simulation tools on the internet. You can place your location and they will give you this kind of heat map where they will tell you, okay, in this area you can expect better signal, in this area you can expect weaker signal, but they cannot tell you on what spreading factor you can expect that and what signal quality you can expect. LoRaWAN is pretty robust, but to confirm that your network is good, that your deployment is good, you need to make some kind of testing. So just recently we deployed in my hometown one gateway. We placed that on the Things network as a public gateway. So I went around to make testing. I take my bike, drive around with a device, and make some mapping. These dots represent the location of the testing, and the blue rectangle represents the gateway location. Gateway is pretty high above the roof, so line of sight in the whole field is pretty good. This is the result I got. So this is the heat map. It is generated in our GLAMOS application. So the red color represents the better signal, the higher RSSI value, while the more blue it is, it says that signal is weaker. But sometimes it's hard to compare just colors, and for that purpose we also generated this 3D coverage heat map. So based on the height of these bars, you can understand where signal is better. Looking just this heat map, you can see that on the left side and the right side, the further you go from the gateway itself, signal is becoming weaker. What does it mean? Is our setup good or our setup is not so good? Then I went to one building, and as you can see here, on one side of the building, signal was available. I was able to communicate with the gateway, while on other side of the building, where red dots are, signal was not available. So having coverage does not mean a lot. Having general coverage does not mean a lot. Some network providers tells you, okay, 99% area is covered, but what does that mean for your use case? So each use case requires specific testing, each use case requires specific setup. We need more details. We want to know, okay, is that 99% coverage only at one location with one spreading factor or all spreading factors? But what is the situation indoor? When you get indoor, it's complete different game. So in indoor, you have many different obstacles, many different obstructions that can affect your signal quality. A lot of walls, different kind of walls, metals, glass, some kind of tables. People are moving around, and that can complicate things a lot. So this is pretty big building. It's like 2 football fields. And we decided to make small testing to showcase you what can you get and how to plan your network indoor. So is one gateway enough to cover whole building or to cover whole plant? This building has 10 floors, so it is pretty big, but we decided to showcase you at least on few floors to understand how many floors can you cover with one gateway or multiple gateways. Maybe 2 gateways are good enough, one at one corner of the building, other on the other corner of the building. But how to know that? So we bought one of the things indoor gateways. It is pretty small gateway. It costs around 100 euros. We deployed that at one location in the building, and we took our device to make testing. So we took our device. Inside of the device, you have the menu where you can say, okay, I'm on location number 1, I'm on location number 2, 3, 4. Why is that important? Because non-field tester or non-GPS checker does not have GPS signal indoor, so we cannot coordinate ourselves while we are indoor. And this is the result we got. So at the floor where gateway was deployed, we had pretty good signal coverage. You can see that with spreading factor 7, which is less robust signal quality, we also had pretty good signal quality. You can see at every corner we had some communication. And also with spreading factor 11, which is more robust, we also have, which is of course logical. But that was on the 5th floor where gateway was deployed. What is situation on the next floor, one floor above the gateway? If I show you this heat map, this coverage heat map, you will say, okay, signal is good, coverage is good. What does it mean? Okay, we have the signal coverage at all corners of the building. We can see that with spreading factor 11, our gateway is covering. So gateway is one floor under this location. This is the spreading factor 11, so pretty high spreading factor, and that can affect your battery life a lot. This is also the 3D view of your heat map, so also generated in our application. Looking just height of these small bars, you can understand where is the better signal and what can you expect with your devices. So if you deploy your sensor at the red corner, you can expect high RSSI value, while on other corner of the building you can expect lower quality. But here is a real situation. With spreading factor 11, we had pretty good coverage. Whole floor was covered, but with spreading factor 7, at least half of the floor was not covered. Why is this important? You want to deploy your sensor, but your sensor will not work with spreading factor 7 in this area, but it will require some higher spreading factor. Okay, but what does that mean? How spreading factor affects your battery life? Every time you increase your spreading factor or data rate value, your battery life will be cut by half. So if your device is declared on 10 years battery life with spreading factor 7, you can expect that with spreading factor 8, your battery life will be 5 years, then 2.5 years, and with spreading factor 11, only 0.6 years, which is just 7 months. So your device has declaration on 10 years battery life, and you just get 7 months. Where is the problem? Problem is the coverage. So I made small calculation. Most of the companies, when they make network, when they provide offer to the investor, to the owner buildings, they want to reduce number of the gateways. Why is that important? They want to reduce cost. They want to reduce initial cost to make investors easier get involved in IoT. But that's not good approach. Why? Okay, you bought one device, it can work on spreading factor 7, your battery life is 10 years, we calculated that one battery costs 8 euros, you take 6 minutes to go to disassemble your device, change battery, put it back to confirm that it works again, and total cost is 10 euros. Then you take this device, and in 10 you need to change battery every 7 months, because on spreading factor 7, your device will lose his battery every 7 months. So in 10 years, total cost of maintenance will be 160 euros just for one device. What if you take 100 devices? The floor plan I showed you is 100 times 100 meters. So it is pretty big building. You can expect a lot of sensors in every room. So 100 devices is pretty optimal number of devices. So check this now. Your cost of maintenance is just 1,000 euros for 100 devices in 10 years, while in this case you need to it will cost you 16,000 euros. So increasing spreading factor is not just some parameter. It costs you money. It costs money your investors. Then is cheaper more expensive? Sometimes yes, sometimes no. But what I wanted to say you need to take in account all things you want. Okay, but what if we in that area which was not covered, we bought one more gateway, it costs 100 euros, we deploy one more gateway in that area, and our devices now can work on spreading factor 7. So our cost increased just 100 euros, and we reduced total maintenance cost by 15,000 euros in next 10 years. Let's sum up the whole presentation. Talking about general coverage is not a good approach. You need to ask more things. You need to ask and understand what does your coverage mean? What can you get from that coverage? Each use case requires specific conditions because, for example, water meters requires higher redundancy because you want to more gateways cover. If one gateway go down, you want to have coverage anyway. You cannot get the real results with simulations only. You need to go on the field and you need to check if some wall will affect your signal quality where you want to deploy your sensor. And indoor deployment is completely different. A lot of walls, buildings, some buildings are created like Faraday cages, so you cannot get any signal going out of the building. And visualization can help you a lot. Signals, wireless signals are something invisible. We cannot feel it on our skin, so it is important to get some kind of visualization. Spreading factor is the most important factor for long battery life. This is the thing I wanted to say you to remember, because that's the factor that is not calculated a lot. It is not taken in calculations, and it is really a really important thing. Don't optimize the setup by reducing initial costs. Optimize setups by increasing costs if required, but get the most optimal setup for future usage, for longer maintenance. Because when investor give you money at the beginning, later that will increase your cost, that will increase all the problems that can be there. So let's make IoT together by good approach and good planning of the LoRaWAN networks. Thank you.